The first question is describe the behavior of logic versus bitwise operators on multi-bit vectors in Verilog and their common pitfalls. So you can pause this video, you can think of the solution and you can answer this. Yes, so let's see the answer. I hope you have answered this. See, basically bitwise operators are logic bitwise and bitwise or bitwise XOR bitwise not operate element wise. For example, if I'm going to have range 3 down to 0 a comma b which is equal a comma b, and if let's say a is equal to floating binary 0101 and b is equal to floating binary 1101, then if I'm going to perform logical AND operation between these two variables, then bitwise I mean if I perform bitwise AND operation between these two variables, then bitwise operation will be done. For example, 0101 1101, and my resultant will be a 4 bit, right? But in the case of my logical operators, if I'm going to use logical operators and if I'm going to perform logical or operation logical and operation or any other logical operation between these two variables, then my final resultant will be only 1 bit. Here if I'm going to use logical and operation, obviously there is loss of my information, there is a loss of my data, right? So this is what it is written over here: reduces any non-zero vector to 1 and 0 to 0, producing a 1 bit result. And what is a pitfall here? So using the logical AND operator instead of normal bitwise AND operator, in the case of my assign statements for 8-bit masking, will reduce the operands to 1 bit scalar, losing the particular information. Obviously, we are going to lose our bits. That means we are going to lose our information, right? So that is the main pitfall I'm going to have over here. So here in this particular example, you can see over here it's 7 down to 0, A is equal to this and B is equal to this. And if I'm going to perform bitwise operation, this is my correct AND operation result. But if I'm going to perform logical AND, then my final result will be 1, right? And obviously I'm going to lose my whatever the data information or whatever the actual information, right? So that's the reason I'm not going to use logical AND operation. Logical AND operation or logical operators should only be used in your condition checking, like if you're going to use if else block or else case statement. In that particular cases, you can use logical operators. But normally, if you want to perform normal AND operation or operations, you are going to use normal bitwise operators. So that is the answer. So describe the behavior of logical versus bitwise on multi-bit vectors and common pitfalls, right? Yeah. So let's see next question. So how does Verilog's implicit net declaration rule interact with the vectors and what bugs can it introduce? So you can think of this particular answer and pause the video and resume for cross verification. Yes, I hope you have answered this particular question. See, let's say suppose if I have a module declared and the module name is example, right? And this module is going to have two wires A comma B, right? And let's say somehow I'm going to write down assign C is equal to A bitwise AND operation with B. Now, here I haven't declared any here I haven't declared any particular variable C, but if I'm going to run this particular code in my simulator, there is no error it is going to give. There will be no compilation error, and the C will be declared implicitly. So this is nothing but my implicit net. Now, to avoid this particular type of implicit nets to be created and to my compiler to let me know that there is an error and C is not being declared, to show me that this C is not being declared and not to create this C implicitly, I'm going to use some keyword which is known as tick default underscore net underscore type, which is none. So if I'm going to use this particular compiler directive, it is going to make sure that no implicit nets have been created. No implicit nets have been created. So this is how I'm going to use, and I'm going to make sure that no implicit nets have been created. And it will basically remove the bug, which is nothing but implicit net creation bug, right? Yes. Now let's see next question. So that's about this particular video. So if you like this video, please like, share, and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.